Okay, so I've asked the panelists to introduce themselves, just to give them a couple of minutes. Probably they will go a little longer than that. But I think you have an incredible cross-section of individuals who have an interest, not necessarily in seawater concrete, but have the knowledge that we need to make this technology real. And so I'm not going to introduce you. You can introduce yourself. We start with Professor Sutter, who is also, I was going to go to the football team that you have that is not the most exciting one, but okay, we'll talk about football later, but you can introduce yourself, and when you're done, pass the mic.
Yeah, you have my interest now. I'm not sure which football team that is. So Larry Sutter, I'm a consultant. As Dr. Nani indicated, I am the Vice Chair of C9 at ASTM. That's the committee that oversees concrete standards. I'm also the chair of CO9.24, which is the subcommittee that writes specifications and test methods for supplementary cementitious materials. And then also chair of subcommittee 1.14 on the C1 side, which is non-hydraulic cements. So I'm very involved in ASTM and development of ASTM standards and specifications. And I am probably the least knowledgeable of seawater concrete of anybody in this room, because I live on the shores of Lake Superior, which is the largest freshwater body, and one of the largest freshwater bodies in the world. So I'm actually here to learn. We had an introduction to seawater concrete at ASTM in the summer meeting, and had some preliminary discussions about it. And the fundamental question that was asked by most, by everybody really, was what can we do? What is needed from ASTM? And I will share with you the two pearls of wisdom I share with everybody when it comes to ASTM. Anything is possible, but nothing happens by accident. So you need to be there and be driving what's happening and pushing for it, advocating for it, working on the language. Anything is possible. So what I hope to come away with from this discussion is some action items that I can take back to ASTM and say, this is what we like to do. One of the things that we discussed at the meeting in June was a formation of a committee that would oversee this particular subject. It's not clear if that's the right approach or not. Really depends, again, on what actions need to be taken. Does it make sense to have seawater integrated into the existing subcommittees, or would it make sense to have it as a standalone subcommittee? Those are all things that we need to discuss and figure out. But again, I'm here to learn what is needed, and from there we'll decide a path forward and figure out how to make things happen for you in seawater concrete.
Good afternoon, everybody. My name is Jerzy Rzemaitis. Jerzy, not from New Jersey, in case somebody forgets my name. Originally came from Poland. I spent several years studying concrete corrosion issues. My background from Poland was structural design. From Virginia Tech was durability and service life modeling, especially when it comes to corrosion. So I'm a little familiar with the topic. Oftentimes you say, you know, who is the expert? You know, young people usually know everything about everything. You know, they have the opinions, and then as you specialize, you know more and more about narrow and narrow topics, so eventually you become expert in nothing. So I hope we are all somewhere in between. I've spent several years with a consulting company, CTL, Construction Technology Laboratories, investigating many different things and advocating for service life in structure, especially when it comes to corrosion. More than 10 years ago, I joined ACI Engineering Group, and 3 years ago, I joined NACS, which is the first ACI Center of Excellence, the one for non-metallic building materials. And I'll be happy to share a little knowledge that I have with you. By the way, Frank will be talking about new just in a second. We have a session co-sponsored on Tuesday, so everybody is welcome to learn about low-carbon concrete and non-metallics role in it on Tuesday. Thank you all for coming, and we are looking forward to your questions.
Thank you, Jersey. Nice segue to the second Center of Excellence that ACI formed, NEW. And that's not an acronym, that is a play on the words carbon neutral, just so you know. ACI Center of Excellence for Carbon Neutral Concrete. I'm the Executive Director, Dean Frank, structural engineer. My background is quality and sustainability, so I have a keen interest in this subject matter. Both of them are going to play a big role in the success of seawater concrete. So obviously there's some sustainability related issues to this subject, and what we've found so far with NEW is that there's not one single technology or material or solution to get to our carbon neutrality goals. So we have to consider everything at this point. So it's an exciting time to be in the concrete industry, but also very challenging, of course, because there are so many variables associated with it and so many stakeholders. And so NEW, we focus on several things. We focus on collaboration and coordination. We focus on identifying high potential solutions and trying to get them out to market, educating people about those solutions and seeing them get adopted. So that takes a tremendous amount of coordination and collaboration. We also identify solutions through a validation and verification program that we're just now going to be launching. And that will be validating and verifying environmental claims that folks are making in the marketplace. So I think we've got a lot of things that will be helpful to this topic. Happy to see progress made, and anything we can do to assist, we're happy to.
Thank you. Good afternoon, everyone. My name is Ahmed Shirem. On my team, now I'm responding to Dr. Nani's suggestion. It's Go Blue, the real UFM. Of course, I've been back study at the University of Michigan, so that's the idea. I was in the academia as a professor of civil engineering at King Saud University, where I spent more than 2 decades. After that, I spent about 7 years with the Saudi standards and Saudi building code. And after that, I joined NEWM back 4 years ago as the director of code and standard, and I work for the line. So in this project, really, I don't know why I'm part of it, but they convinced me to be part of it. So OSP colleagues and Dr. Nani, they somehow tricked me into be part of it, and I'm proud to be in that. I mean, it's very, very interesting and very strategic things to do. I'm happy to be working with this team, and of course, I've been in a relationship for the code and standard with the ACI. It started more than 22 years ago. So I remember the first MOU that I contacted ACI to do was in 2002. So we are in the Saudi building code. There's a relationship with MOU with ACI for concrete. So Saudi codes in concrete is according to ACI, modified version of it, and other codes with the ICC, and this is part of a relationship between Saudi Arabia and most of the organization producing code and standard in the United States. Thank you very much.
Well, I just spoke. My name is Mohammad Kalimur Rahman, and I'm at IRC Construction and Building Materials, a researcher there, and a faculty in Civil and Environmental Engineering Department at King Fahd University of Petroleum Minerals. And we do basically a lot of client-funded research project at this IRC for Construction and Building Materials. In addition to these projects on GFRP and seawater concrete, we are working with the NEOM to develop a 150 megapascal UHPC using local materials in NEOM, and We have succeeded to get about 170 there, and several other projects like that. And I'm a voting member of the ASI Committee 243, and hopefully, together with all the committee members, we will contribute to make this a real good success, because I'm enthusiastic looking at the results which we got for the really one extreme end of very hypersaline seawater and sea sand and the brine, giving very good results. So hopefully, this committee will successfully develop whatever is needed to make seawater concrete as an option, and an option with really lower carbon footprint, and being economical also and useful in all those countries where the freshwater sources are scarce. Thank you.
Yes, hello again, everybody. I'm going to reintroduce myself. My name is Abdullah Gahtani. I work for the Oil Sustainability Program, part of the Innovation and Technology Management. To be honest, I'm very humbled to be around this group. I have no PhD degree. I don't have any previous experience in academia. And also, I think I'm the youngest one around this table. So I think, I hope that I can bring, with this little of experience that I have, a very good input into this panel discussion. So, yeah, in the innovation and technology, we work, we scout all technologies that are aligned with our mandate. We bridge the gap between the R&D or the academia to industry, trying to push several technologies, several methods into the market, one of which is the saltwater concrete. Now we're working on. So we're providing the necessary enablement packages, we name it this, for these technologies, in terms of funding, in terms of connection, in terms of scaling up. And this is what brought us here today. So we can have different perspective from different angles, from different backgrounds into this project. In hope that we can see this project in upcoming future a reality. Thank you.
Thank you, Abdullah. So, hi everyone. So this is Mohammed Kanwi from the Oil Sustainability Program again. I'll echo my colleagues what he said, I'm really humble being with this. I would say old folks with a rich experience. Really glad actually to be among you guys, but let me say this one to just for the sake of ice breaking. So I'm glad I came back to Pennsylvania State, because I'm really graduated from Penn State University back in 2015. So it was really something great. I would like to share it. My background is plastics and polymer engineering with a bachelor degree, and then later I got my MBA. I started my career experience working in the petrochemical field as a technical marketing and product development engineer, and then here I am in the oil sustainability program as a business development, where basically I'm trying to promote those technology and make it ready to be used for end users. And basically, as my colleague Abdullah has highlighted here, I wouldn't say it, but it's worth to say it. Okay, we wish to change the word when it comes to the oil-based material to be utilized in any things that really touch the building and construction and water and you name it. So really glad to be here, and wish I just can add as much as Abdullah can say. I will not say the PhD guys, and you never know. So one day maybe I'm going to get my PhD and be really colleagues to those gentlemen here. Thank you very much.
Hello, my name is Marie Jackson. I'm a research professor in the Department of Geology and Geophysics at the University of Utah. I actually prepared a 4-minute little remarks, which I thought everybody was. So I hope you don't mind if I share them. Here goes. Sustainability has many different meanings in the world of seawater concrete. I I would like to offer you some of my perspectives based on my studies of ancient Roman concrete structures in marine harbors in the Mediterranean Sea. A Roman approach inquires, how can the interactions of concrete structures with the marine environment contribute to long-term durability and resilience? These are structures in the sea that are constantly interacting with that medium. How can the seawater improve them? Well, the answer to this requires a holistic approach to environmental sustainability, which Roman engineers actually mastered 2,000 years ago. How do we create concrete materials that interact beneficially with seawater? How do we integrate these innovative concrete materials ecologically to improve durability? And 3, how do we integrate these concrete materials hydrologically and geomorphologically to improve durability? Those are 3 big questions for sustainability. And some of these concepts are currently being employed by the Engineering with Nature program at the United States Army Corps of Engineers, which I am actively contributing to a project there now, and also at the Center for Coastal Climate Resilience at UC Santa Cruz. And the objective is to design and place concrete structures that work with the energy of natural systems. This is the only way that we can make concrete structures that will indeed stand the test of time. Finally, there's a 4th quality that Romans understood, and this is the quality of self-sustainability. Beyond environmental sustainability, how does the structure sustain itself? And Pliny the Elder described this in 1st century BC. He emphasized rock-like cementing processes where the concrete becomes a single stone mass, fierum unum lapidum, impregnable to the waves and every day stronger. 2,000 years later, these structures remain functional and intact. We have a great deal to learn from them, and I hope that I can contribute some of that knowledge of Roman engineers to your perspectives as well. Thank you.
Okay, yeah, thank you, Mary. Very, very inspiring. It's difficult to talk after that, but anyway, good afternoon, everybody. I am Liberato Ferrara. I am professor of structural engineering at the Department of Civil and Environmental Engineering in Politecnico di Milano in Italy. And I have been active in ACI. In the past years, I was chair of the ACI 544 Committee on Fiber Reinforced Concrete, which was my main, and is still my topic of research and profession. From FRC, I went into UHPC, and there I started being interested in the effects of chlorides and salt water and marine water, because we had a large project funded by the European Commission on the resilience of structural coast defense and infrastructures for energy harvesting. And from UHPC, we went into self-healing, which was something for the self-sustainability of a structure. And we discovered, and we are still working on that, that in some cases the chloride may make it better. So enhance this capacity to the chloride binding that Tony was considering. Going back to what you were saying, there is not a single technology, but rather an ecosystem of technologies which work together. Definitely, I see this seawater concrete, but also use of local resources, recycled materials, different kinds of reinforcement, non-metallic. We are working now with amorphous alloy fibers, for example, that are potential candidates to replace steel, as something which have to go into a synergy to produce a material, produce a technology, produce a product, guiding us, because let's not forget we are in ACI. ACI develop codes, so a methodology to design, to approach the design of these new materials that we have in these challenging conditions, to which unfortunately we have to be used more and more frequently, and also to be able to effectively cope with the most dramatic consequences. We have all seen the images from Spain, which are tragic, and this is becoming, I come from Europe, from the Mediterranean, and we are experiencing far more and more frequently these conditions. So definitely I think that, trying to do more with less, or to do more requiring less from our planet and using what do we have locally, it's something that we have to learn, and probably this is a contribution that this committee and the interaction with other ACI committees can bring.
Wonderful. So now you got to know our 9 panelists. It's your time to ask questions, tough questions. I'm going to ask Nima Kodadadi if you could be kind enough to take the mic and just reach the person who's asking the question so they can be heard. Who's going to take the first question? Please. I mean, all this beautiful. Maybe introduce yourself, just a name and...
Babar Ismail. I'm a structural engineer from NEOM. My question is to Mr. Kalimur Rahman. It was a nice presentation. Did you do any study in terms of extrapolation to see what's the design life that you achieve out of the experiments that you did? Yeah.
No, we are in the process of doing that. Not yet studied, but I think so that initial assessment shows that the lot of saving in terms of utilization, non-utilization of fresh water, which in Saudi Arabia, as mentioned earlier, Abdullah, that it was all coming at a high cost, being desalinated, So if we can use that seawater in concrete, then of course, it will be really very cost effective. And once we are also able to ensure that the required service life is achieved, like if we can say that almost like we can achieve 100 years because there is no corrosion issues, especially if we are using the GFRP bars in this concrete with the seawater, then also that will be a big advantage.
Thank you. Next question. Yes.
Yes, good afternoon. I'm Marwan Day, a long-time member of ACI, and I've been working with nuclear, industrial, and oil and gas during my career. I like to ask the panelists, first I like to commend you on the idea and the approach and the research that you're doing, and I believe it's going to come to fruition and helping the environment and the economics of the concrete. I was wondering how come you didn't address the savings and the of the corrosion and the corroded material, concrete, and the repair of the concrete that we've been dealing with for the last whenever. So I hope you address that, because it's the benefits of saving from not having to repair the concrete or demolish it is astronomical. The question really follows the first gentleman, is what is the long-term effects of using this concrete, and specifically with the fiber reinforcement because of embrittlement, etc., that could exist.
Excellent question. Actually, a difficult one. Who wants to take it?
Try.
Brief.
I think very good question. It's really related to the newness of materials and solutions that are in front of us. And that's the wisdom that ACI managing directors had when they established the center, our center, NACS, and other centers as well, to reach out to you guys, to the industry, to address those issues. And it's through addressing of developing some of the documents that are needed, educational resources that are needed, funding research that is needed, to find out what those solutions are and what are the long-term effects. Do we have the answers? No, but if we don't seek them, we'll never know them, right? So that's why we, I can speak for myself, we fund a lot of research related to FRP bars, whether it's durability related, whether it's applications in seismic zones. We are there, we try to do that. But sometimes, accelerated testing is good but not perfect. Like Peter Schiessel, doctor from Germany, many years ago said, when you have a baby, you don't put the baby to 100-degree water Celsius just to test, how it's gonna last after 3 weeks of bathing. You bathe every day at, 28, 30 degrees, right? So again, we are trying to find out. We are reaching out to the best researchers out there through the universities in the United States and nationwide and worldwide, sorry, and we'll get those solutions. But I'd like to also commend Dr. Rahman and NEOM and OSP that sometimes you want to find out the solutions and find the reasons why things happen the way they happen, but sometimes you also want to test things out. You have to try things out and then to try to find answers why are the things happening the way they are happening. But very good question. We definitely need to address them.
Thank you. Is a question? Oh,
Can I just add one thing? This is probably not a fair question, but would you see that this advantage applies to a high-rise building, etc., or are we limited to infrastructure such canals, pavements, or other structures of that nature?
I'll answer that question. I think in my mind, you need to walk before you run. The challenge of high-rise buildings is perhaps different. I think just the amount of concrete that goes in paving application is unbelievable. So I think the answer to your question, that is again a very hard question, is let's perhaps start with the application that are not as life-threatening as a high-rise building. So I think we will get there, but no rush. No, we'll get there, but we need a little time. Another question, I think in the back. Yeah, perfect.
Sure. I'm Jeff Rogozinski with Sherwin-Williams. I was wondering, is anyone investigating epoxy-coated steel reinforcement in this, besides just FRP?
The short answer is no. I think this ship has sailed. Again, I'm not saying anything against epoxy-coated bar. This has been studied for many years. In the 90s, you go to TRBs and probably the recordings are there, so you'll find it there. There are some states who say it's awesome, it's great. West Virginia, for example. There are some states, Florida, Virginia, say not so much. I think it depends on the environment and where you are. It's under film coating issues and corrosion under film. It provides some extension of service life in some environments, not so much in others. And then somebody may ask a question, how about the cladding bar, right? You have the stainless steel on top of it. It's the issue with fabrication and you name it. I think when it comes to corrosion, FRP bars is unbeatable, but there are some issues with that as well. It's not maybe perfect for seismic zones, and that's why more research is needed. But at this moment, I think we are trying, or I think that the committee is trying to find solutions that go beyond conventional steel. An epoxy-coated bar steel is regarded as conventional steel, even though it has the coating. But good question, thank you.
Actually, are you going to epoxy system. Well, the reason I bring it up is because it's very similar to what Aramco is currently using for offshore pipeline protection. So this is where it's direct to metal.
I've heard of it. I'm not familiar with that. But I've heard of it. But I think it has been existent for like at least 8 years or so, right?
No, the ESKIM is since September of last year.
Okay. Well, I don't know much about that. Anybody?
Question or answer? Please.
Thank you. So it's very interesting to see this in situ manufacturing or in situ construction happening overseas and using indigenous materials, because this is the only way we can provide sustainable, environmentally friendly and durable structures. I'm a firm believer if you use your local materials in order to produce something that is sustainable. My question is, are you going to be limiting the research to the hypersalinity water, or you're going to be open to use any water or even dilute the hypersalinity water with something else that could provide another sustainable or a more sustainable solution for the concrete mixes?
Well, I think so that when we test at that other extreme end, then we have the highest threshold known. So anything below it, normal seawater, or like the seawater which has very low salinity. In those cases, I think so this all will be like functioning well. I mean, we won't see any problem, you know. The reason for testing also that in those areas where we are concentrating, you know, there is a lack of fresh water, and we need to construct really structures over there, especially such type of concrete for mainly infrastructures, coastal infrastructures, and industrial infrastructures like pavement and other things, with the huge development going on around that coastal area. So even with this type of high salinity water, the concrete mixes, we have checked it in all various angles up to durability, especially long-term durability is still under consideration. It works, you know. So hopefully with all other seawater around the world globally, it will work, and I don't see any problem in that respect.
I have another follow-up question, if you allow me. Do you treat the water in any way? Just you use it with all the microorganisms?
We didn't treat the water with any way. We didn't treat the sand with any way. We use exactly as it is available. And also, I wanted to add that in deep desert, you know, accessibility is very limited. And sometimes, you know, we need to construct facilities, especially oil and gas, where such type of concrete can really work a lot, you know, where even the concrete trucks cannot go. But a lot of brackish water is available, and this highly saline brine water is available.
Are you seeing any interactions between chemical admixtures and the water, the high salinity water, and kind of what that could mean for higher performance concrete? Interactions between chemical admixtures like air entraining agents, superplasticizers, et cetera, with the high salinity water?
No, we didn't. I don't think we saw any interaction between that and when we wanted to achieve a particular slump retention, we increased the dosages of the high-range water reducing admixture, and we didn't see any effect on any other property, you know, other than improving the flow and slump retention.
Excellent. Maybe questions that are less detailed, more, let's say, systematic. We have a lot of people here who are eager to talk. Maybe a question for our friend ASTM. Please. By the way, I need to pay all the gentlemen after this event. The panelists are very...
They were paid by the question.
So, yeah, hopefully this is less technical, but I will just refer to the technical work done by Dr. Kaleem. So it seems like the technology is, at least based on the initial results, the technology is solid and it's kind of ready for commercialization. How ready are we to commercialize the production of such concrete?
I think more than one person should address that.
I have my own question. I'm going to let someone else address it.
Dr. Schrain, you want to?
Anybody?
What would you do to commercialize this technology?
Well, thank you. What I was trying to say really, what Dr. Kalim presented here is very, very great information, experimentally, etc. Now, in order to convert that and to say, okay, now I need to use it in real projects, then that will not be just based on these results alone. You need to move it you need to go to the standardization and to regulation. That's the way how we will because in real life, nobody going to construct anything, consultant or owner or anything, just because, well, somebody did that test in that university. With all due respect, that's not, but that's real life. So it has to be, and that's what we are intending here in this committee, is to take and also with ASTM, is to go and standardize part of it at least. So when we're standardizing for the seawater, for example, we have to be limiting that within certain boundaries so it will be, once you are outside that boundary, you will not be using it. I'm talking about the chemical boundaries. Similarly, so that's basically the need or the intention of this committee, and that's the whole idea, is that we need to get sufficient information with so many repetitions and controlling things, and then to lead it to have a clear characterization, and that will be reflected in documents based in ACI and also in ASTM for the materials, and then you can talk about commercializing the issue. So I think that's my general understanding of the issue.
Maybe OSP could give a perspective. What would you do? What are you doing to commercialize those creators in the...
Yes, I'll echo what Dr. Shraim just mentioned. For this particular product, when it comes to building and construction, there is no... so the design offices, project owners, will not just simply adopt or embed any technology, any materials to their project unless it has been backed up with standards and regulations, and at least has been shown in some pilots or cases has been shown before. And this is what are we doing with Novus Crete. So we do have it at this saltwater concrete project. We do have several work packages. The work packages range from mixed designs till the pilot and standards and regulations drafts. Now, what we expect by the end of this project, what we aim for is successful pilot, codes and standards for this project. If we do have these three, then we can go to the commercialization stage with full confidence. The pilot that we have chosen for this project is non-structural, not life-threatening pilot. We've chosen a pavement pilot. We've chosen another pilot for raft slabs for wind turbines. So these type of cases would make us climb the ladder step by step. So we're starting from the lowest until we reach, hopefully, be very optimistic, we reach very big buildings with saltwater concrete.
Before I give the floor to Professor Sutter, let me also ask the question to Professor Jackson, how much more do we need? You just told us that these structures that have been around for 2,000 years. So, rightly so, engineers need standards, they need specifications, but is there something that we can do based on what we have done as a culture, as a society 2,000 years ago to implement this technology? What's your thoughts?
Absolutely. I don't have the answers, of course, but when I hear that structures are being designed for 100-year service lives, that's a minuscule amount of time for something to be functional on the seafloor. This is not a structure on land that we can easily repair. We need to be thinking differently about material properties. What kind of ductility do we have? What sort of ability to repair the material itself when fractures form? How does the seawater that percolates inevitably through the concrete interact beneficially with it? As long as we're thinking about reinforced concrete structures that are supposed to be sealed from the seawater environment, even though they're fabricated with seawater, we will be leaving a terrible legacy for the generations behind us. And we will be really doing damage to the coastal environments that we already know are so susceptible to damage now. Even from the point of view of glass fiber reinforced concrete, that is garbage that will be rolling around on the seafloor 100 years from now in a structure that has a 100-year service life. How can we rethink reinforcement in structures? Are super high strengths really even necessary in a lot of marine construction? These are questions that the Romans themselves faced, and we can read a lot of the answers to that in those materials. We're doing a lot of work now reproducing those mixes, really precise reproductions of those mixes to be able to answer those questions. So thank you very much.
Professor Sutter, you have a question?
So as I said at the start, I'm here to try to figure out how to help you. How can ASTM serve this community and provide you with what you need? So we talk about standards very generally, and we need to be more specific. And there's a couple things that I think we need to keep in mind what these documents are. When we write a material specification, it's not a textbook, and it's not a research paper, and it's not a design criteria. It's the basis of a purchase agreement between a buyer and a seller to buy a material. Okay, so C94, for example, is the basis of an agreement to buy ready-mix concrete from a ready-mix concrete producer. So the question that we have to ask in ASTM is, what do we need to change in C94 in order to allow seawater concrete to be produced? We need to think about what are the specific hurdles? And the same thing with test methods. The test method is going to generate a result. Based upon that result, we can set a limit for a certain property. So what properties do we need to measure? What tests are we lacking in order to be able to specify and use seawater concrete? And there's a number of people in the audience here who I assume have an interest in doing this or have done this. You made this material, so what are the hurdles? What specifically can we tackle to help solve this problem?
I don't think we have an answer to your question yet.
No answer is okay. But we still need to come together then. So those of you who are very interested, you need to come to ASTM. We need to get together and answer that question. Because until we come up with the answer to that question, I can guarantee you that nothing is going to come out of ASTM. Nothing happens by accident. It happens by you being there asking for specific things to be done, specific documents to be written, and then you roll up your sleeves and you help write them and you help pass them.
That's for sure.
Can I ask you a question?
Yep. Now, okay, now we've got the panel that you need.
Okay. So the question, what will be required by ASTM if we came, let's say, Dr. Kalim or myself or any one of the whole team, and say, well, we would like that committee to accept the seawater and to consider it part of the requirement, to be part of the standards. And what will, you are going to ask questions, what do you have? So can you specify, in general, of course, what you will be asking us to provide in order ASTM to be happy with what we are doing?
So I assume we're talking about the specification for ready-mix concrete. So we would look at that specification and say, okay, what prohibits the use of seawater in ready-mix concrete? And right now, in that specification, there's nothing that prohibits the use of it. Now, it does require that the water should meet 1602, but it also states that if another specification is applicable, that could take precedent over C1602. So do we need to write another specification for seawater that would be used instead of C1602 for mixing water? Or, there's a number of different ways you could approach it. But the key is, it isn't necessarily the committee. The committee is the industry. Everyone in the industry is serving on that committee. And so the committee is not a higher body that's going to make a judgment. The industry makes a judgment. And through the committee, we jointly write a document that's going to help us accomplish that. So we would turn around back to you and say, again, the question I asked you earlier, what is holding you up? What is the hurdle? What language in here, specific language in here doesn't work? And then if we need to strike it, we can talk about striking it. If we need to add to it, we can talk about adding to it. But until we know what your hurdle is, we're just sitting here staring and wondering how can we help?
Thank you. I'm Caitlin Tibbetts. I work for the Army Corps of Engineers. And my question / comment would be to kind of piggyback off of that. So I would see an ASTM probably having different levels of salinity for seawater, because there are going to be differences like across the world as far as like the high salinity versus something that's more brackish. But I imagine that would also greatly affect the ultimate performance. It's going to interact differently probably with different SEMs, potentially different aggregates long term. So I guess my question would be, if the goal would be to kind of make an ASTM and have these different levels, is the committee intending to maybe make a checklist for different researchers to say, okay, these are things that that need to be reported, so that as we're collecting data to kind of influence an ASTM, we have an idea of thresholds or ranges for this salinity gives you this performance, this salinity gives you this performance, to where in a specification they can say, for this application, we want tier 2, which is, has shown good performance for this type of thing, which might be associated with kind of a water cement ratio, a range of SEMs, that kind of thing. Because I have done projects using seawater in concrete. Of course, it's for Army, so it's short term, and they have a very narrow insight for like what they're concerned about. But if there was kind of a list of, these are the things that we would want reported to then inform a decision for specification, people that are doing research could maybe try to be on the same page for what they're reporting and how they're reporting it, so it can be aggregated into kind of one document.
This is an excellent comment question. I think you are indicating to us potentially the avenue, that is, like we do specify ranges for concrete strength. There could be ranges for salinity or other, constituents, for example, the phosphates and the sulfates and other things. So clearly this is in the hands of the committee and the researchers.
So the scenario you describe could make sense, and so assuming that that's true, the way to approach it then would be to come to the committee with the data, showing that level A, here's the type of performance we get, level B, here's the type of performance we get, and then establish limits for that. Typically now with C1602, we test the strength of a mixture compared to a control. So I'm sure we'd probably take the same type of approach there. And it's a matter of going to the research that's been published, pulling that data in and using that as the basis for writing the limits. And so what you described to me would be a new specification for seawater for use in concrete as a mixing water. So you wouldn't want to go back and change C1602. We'd probably write a new specification and base it on kind of the framework you laid out. If the data is there, it's just a matter of sitting down and writing that document up and getting it passed.
With this answer, it's 3:30 at my clock. I can see people waiting in the back. They leave the room. I really thank you for your patience. I hope that this was useful, and we are not going to go away. So please check out what the committee is doing, what the researchers are doing, and we will see you at other events. But don't miss the rest of the convention. There is exciting stuff beyond seawater concrete. Thank you and have a good evening.